Okay, so now that we've already done this particular part of the lab by trying to make a triangle, obviously we know that's not always possible. Okay, let's fill in our notes. And so this should be a review a lot of the way through this. We're going to talk about how you can classify triangles by their angles. Is that first blank there? And by their sides. You can classify triangles by their angles and by their sides. So by classifying by their angles, we have three types of angle classifications: acute, right, and obtuse. An acute triangle will have three acute angles. Essentially, all of them, right, are acute. A right triangle will have one right angle, and an obtuse triangle will have one obtuse angle. What's important to note here is that every triangle in existence always has at least two acute angles. So if you see an acute angle on a triangle, it doesn't mean that it's an acute triangle. All of them have acute angles. But if you see a right angle or an obtuse angle, then you know it's got to be a right or an obtuse triangle. So I know we answered a question like this in one of our other homeworks, I believe. But yeah, so you have to actually look at all three angles. I can't have more than one right angle because what's 90 plus 90? Carson? 180, and I haven't even added my third angle in. And I'm already at 180, which I know is my totals, what they have to sum up or to add up to be for the sum. Obtuse triangles, obviously an obtuse angle is more than 90. So if I add an obtuse angle with another obtuse angle, I'm already over 180. And so I'm always going to have at least two acute angles on a triangle. But if they're all three acute, then I have an acute triangle. Okay, so now by their sides, an equilateral triangle has three congruent sides. Equilateral means equal sides. Like when we did lateral surface area and we were finding the surface area of the sides, not the two bases. So equilateral have three congruent sides. Now, there's also a theorem, which I won't go into, but in triangles that states however many sides of your triangle are congruent is how many angles on your triangle are congruent. So if you have three equal sides, you'll also have three equal angles. If you have two equal angles, you'll have two equal sides. And if you have no equal angles, you have no equal sides. So if all three sides are the same and all three angles are the same, what do each of the three angles measure in an equilateral? Ready? 60 degrees. 180 split three equal ways will give you 60 degrees for each angle of an equilateral triangle. An isosceles triangle has two congruent sides and two congruent angles. And that's what an isosceles triangle would look like. So I'm using the tick marks here to show what the congruent sides and angles are. All three of these sides have one tick mark, meaning they're all three the same. All three of these angles have one tick mark showing they're all the same. In the isosceles triangle, the two bottom angles here are the same. And the two sides that are opposite those angles are the same. The side that has the small angle here has the smallest side. And so that's always true. In a triangle, the smallest side will be across from the smallest angle. And that just makes sense. If I have a small angle, the side across from it's also going to be tiny. If I open up my angle, the wider I make one of those angles in the triangle, the longer that side's going to be. Okay. You can have acute isosceles triangles. You can have right isosceles triangles. You can even have an obtuse isosceles triangle, but you can't have an obtuse equilateral triangle because Brady's already said if it's equilateral, the angles have to equal 60 degrees. So all equilateral triangles are always going to be acute and they're always going to look the exact same. And then scalene, how many congruent sides on the scalene triangle? 0, yeah, not 1, but just 0. Yeah, if you have one congruent side, what's it congruent to? Well, nothing. And that's, I guess you could say you have no congruent sides, right? If you have no congruent sides, you'll have no congruent angles. So on a scalene triangle, you have 3 different side lengths and 3 different angle measurements. Again, the larger the angle, the side across from it is going to have the longest side. So the largest side of a triangle is always across from from this largest angle, and you can say the same about the smallest side of a triangle. The smallest side of a triangle, like this one here, is always opposite the smallest angle. And so because I used 1 tick mark, 2 tick marks, and 3 tick marks, it shows that all 3 angles are different. Okay, so example A. Classify this triangle for me by its angles and by its sides. So let's start off with angles. Alex, would you say this is an acute, right, or obtuse triangle? It is obtuse. Yep, that one obtuse angle on the bottom makes this an obtuse triangle. You only have to have 1. You can't have 3 obtuse angles. You can only have to have 1 to be obtuse. And then now we're going to classify by its sides. Jacoby, would you say it's equilateral, equilateral, isosceles, or scalene? It is isosceles. We have 2 sides that are equal, and you can also see that 2 angles are equal. So if they don't tell you if the sides are equal, but that you can see angles are, it's essentially the same as telling you that there's going to be sides that are equal as well. Okay, go on to example B. What about this triangle, Chloe? Would I say it's acute, right, or obtuse? It is acute. And Connor, would I say that it's isosceles, equilateral, or scalene? Equilateral. Yep, it's acute equilateral. I'll put this down here. And so what does each of those angles measure? Carson? 60 degrees. All equilateral triangles have 60-degree angle measurements. Now, that doesn't mean that they all have to be the same size. The side lengths could be different sizes. I could have a 60-degree angle, and there could be a 10-foot side across from it, or there could be a 10-centimeter side across from it. Right. So just because I have an angle that's locked in at 60 degrees doesn't mean that I can't keep extending those rays and make longer and longer sides. Okay. So even though the shapes can be the same, the sizes could be different. They'll be similar sizes. And then example C, what kind of triangle do I have here, Oliver? Acute, right, or obtuse? It's a right triangle. Okay. And Carter, would you say it's equilateral, isosceles, or scalene? Scalene, excellent. All right, now to the triangle inequality theorem, which I've already mentioned, but now we have it in writing. It states that the sum of the lengths of any 2 sides, I usually just say the shorter sides, but any 2 sides of a triangle is greater than, there's your inequality symbol, triangle inequality theorem, greater than the length of the 3rd side. So again, I usually say the 2 smaller sides have to be greater than the 3rd side. That's another way, the longest side. That's a way you could say it. And so here's your example of a good triangle. 4 plus 2 is 6. That's greater than 5. Here's your example of a bad triangle. 2 and 2 is 4. That's less than 5. And here's your example of Xander's triangle where they actually equal, but the only place they'll be able to touch is right there. We're just making a really thick line, and that's not a triangle either. It's just a really thick line on the bottom. So they has to be greater. So tell whether these can be greater. And so on your worksheet tonight, you are going to show your work. I'm not asking for a whole lot of work, but you do have to show your work. And I don't want just a bunch of yeses or nos, because I could guess that just to get the worksheet done and not learn a darn thing from that. So what are my 2 shorter sides here, Deegan? Okay, so here's how I'm going to show my work on my worksheet. I'm going to say 5 plus 10 has to be greater than 20. Then I'm going to add up 5 and 10. Deegan, what's 5 plus 10? 15. Deegan, is 15 greater than 20? So then I'll put a no next to that, and that's my work. This will not form a triangle. The long side is too long. Example B, Christian, what are my 2 shorter sides? 4. Okay, 4 and 4 have to add up to be greater than 6. Christian, what is 4 plus 4? Christian, is 8 greater than 6? Then yes, this will form a triangle. In fact, I'll go a step ahead. We know it's a triangle. What kind of triangle has 2 sides that are the same, Xander? It would be an isosceles triangle. which you don't need to write on your worksheet unless it asks for it, but this would be isosceles because you can tell two of the sides are the same. As far as acute or scalene or sorry, acute or obtuse or right, you wouldn't necessarily know that just based off of the sides. Although I've got a feeling these sides are so similar in size that this would be an acute triangle, but you can't tell me what degrees they are without actually putting it together. 1.5, 2, and 0.5. Dawson, what are the two shorter sides? Okay, so they didn't give it to us in order this time. So make sure you're not just listing the first two sides, but the smaller two sides. That has to be greater than 2. And Dawson, what is a half plus 1.5? Dawson, is 2 greater than 2? The answer is no. So this one's a no. This is just a really thick line. This isn't a triangle at all. Has to be greater than, not greater than or equal to, just greater than. The last one, 10 plus 10 plus 10. Lizzie, what are the two small sides? Okay, what's 10 and 10 add up to, Lizzie? Is 20 larger than 10? Again, this obviously makes a triangle. And one step beyond that, Lizzie, what kind of triangle has 3 equal sides? Equilateral. So again, I'm not asking you to show a whole lot of work, but I do want to see that you put more effort into it than just guessing yes or no. Okay, all right. So let's go. These are fun. Write and solve an inequality to find the missing side length. So now I'm going to tell you what the long side is. I'm going to give you one of the short sides, and you tell me what lengths would work for the missing short side. So I know that the two short sides, which are 2 and x, have to add up to be greater than 6. So I solved that inequality. What is x greater than?
2.
X has to be greater than what, Maddox? Technically, also has to be, okay. What do I get when I subtract here, Owen? 4. X has to be greater than 4. So I know that x has to be greater than 4. 4 is the small, actually it can't even be 4, can it? Because if it's 4, it'd be equal to. So it's a good thing I don't have an equal bar right here. So I'm going to say x has to be greater than 4, but it would also have to be smaller than 6, because if it's larger than 6, then this was a lie, because they told you 6 was the long side. So it has to be between 4 and 6, which means it could be 5 if it's a whole number, or it could be 4.2, or it could be 5.9. Those would all work. Yes.
And then also equal 6.
That is true. That is true. Because we had an instance of that up here where the two short side 4 and 4, or here in the 10, 10. Yeah, I think that's true, Xander. I think I'm going to have to go ahead and change that. Thank you for correcting me on that. I've had these notes for a while and nobody's corrected me on that. I don't even know where my symbol is.
Anytime.
Anytime? Oh, yikes. Do I not have a symbol for that?
For what?
I'm going to have a math keyboard. I thought that my math keyboard would. Oh. Ah. There we go. All right. Okay, this one's going to take the notch up in difficulty. It says the long side is x. The short sides are 21 and 14. So I know the two short sides have to add up to be longer or greater than the third side. So what's 21 plus 14? What is that, Seth? 35. So x has to be greater. Actually, 35 has to be greater than x. So 35. Is that right? Yeah, I'm doing the long side. So 35 is as long as it can be. So that should go here. Because I want my symbol opening up away from the x, like it is right here. It's opening up away from the x there. Okay. Now, not every value smaller than 35 is going to work though. So my shortest side is 14. My next shortest side is 21. To qualify for the long side, it has to be at least bigger than 21, right? Okay. So I could go down to 21. But 35 is the biggest it can be. No, wait, does that make sense? 21 and 14 is 35. Yeah, 35 is the biggest it can be. So I want to make sure I had this worded right. 21 to 35 then. Okay. Now, the last part of our notes here is talking about unique triangles. A unique triangle has no equivalent, which means there is no other triangle with the same dimensions and shape. It is one of a kind, which I guess you could say is what unique means, one of a kind. So an example of a unique triangle. If I said, I need you to draw me a triangle with these angle measurements and these side lengths. And I gave you a ruler and I gave you a protractor and you guys did that. If I walk up and down the aisles and everybody's triangle looks exactly the same, then that triangle was one of a kind. There's only one like it, it's unique. If I walk up and down the aisles and everybody has a different looking triangle, then it's not unique. For example, if I said I need you to draw me a triangle with angle measurements of 30, 60, and 90. First of all, does it even make a triangle? 30, 60, and 90. Is that up to 180? Okay. If I walk up and down the aisles, I'm going to see some people that drew a really tiny 30, 60, 90 degree right triangle. I'm going to see some people that did a larger 30, 60, 90 degree right triangle. Like everyone's triangle could look different because I never told you how long the sides have to be. So then that wouldn't be a unique triangle because they're all different sizes. They're all similar to each other. Okay. So there are four different conditions to make a unique triangle. And we'll have to talk more about this probably tomorrow before we take our test or our quiz, but I'll mention them right now. If I give you the three sides of a triangle, then everyone's triangles are going to look the same. If I gave you the three, notice there's not one there that says AAA, SSS. If I give you the three sides of a triangle, that's going to give a unique triangle because it's going to lock in those angles. Okay, but everyone's sizes will be the same as well. If I give you two sides and I tell you what the angle between them has to be, that's also going to make a unique triangle because even though I didn't give you the third side, I locked in the angle. So that third side is not going to be able to change because you can't make that third side any longer because it's going to change that angle measurement. You can't make it any shorter. It's going to change that angle measurement. So that's called the SAS theorem, SAS. Okay. Then I've got ASA. If I give you two angles and a side between them, that's going to give you a unique triangle. And the last one, AAS.
Hi, Powell, please come to the office for an appointment. Hi, Powell, please come to the office for an appointment.
And then if I give you two angles and a side that's not between them, that's also going to be unique. So these two theorems right here, basically you could say that, would you back away please? If I give you two angles and a side at all, it doesn't matter if the side is between the two angles or if the side is not between the two angles, it's still going to result in a unique triangle. So we'll talk more about this briefly before we take our quiz, but this will help you as you're doing your worksheet tonight. All right, you guys are dismissed.